Hey, Rachel. How are you?
I'm good. How are you?
Good, thank you.
Good.
Um, I know yesterday in class, our class left off at 24, but obviously I am open to answer any questions that you have.
Yeah, so from 24 to 40. I don't have to have every single one of them, but just like some examples through there.
Alrighty.
Thank you.
So on 24, to determine if a sequence is arithmetic or not, they need to have a common difference. So that means that if you were to, basically what you would do then is subtract the second term from the first and then the third term from the second to make sure that the difference remains consistent from one term to the next. So to do that, negative 24 minus a minus 14 is going to be minus 24 plus 14, which is going to be a negative 10. And then negative 34 minus a minus 24 is going to be negative 34 plus 24, which is also a negative 10. So it is, in fact, arithmetic, and the difference is negative 10.
Oh, okay. I remember this now. What is the one where the kind of sequence where it's not like that? Isn't there a name for that too?
Yes, ma'am. Recursive.
Yeah, that's what it is. Do we need to
Yeah.
know Google's?
No, ma'am. We're not going to have any recursive on there.
Oh, good. Okay, I can do number 25 by myself then. And
Okay.
then for 26, how do you do that? Like, I know that you find the common difference. I think I found the common difference was negative 10. But then how do I get to a to the 35th?
Okay. And so then the next thing that you're going to want to do is figure out what the formula would be. These would be the steps that I would take personally to do this, because part of it is you're supposed to also find the explicit formula. So in order to do that, and then find the name term. So for me, I would find the common difference, which you said you already did, which it is a negative 10. So then, and you will be given these formulas, then you would plug that back into the arithmetic sequence formula, which is A sub n equals D n minus 1 plus A1, which is the first term. So then I would just take the given information that we have, A sub n equals negative 10 n minus 1 plus 34, which that would equal, you distribute that negative 10.
Why is it 34 and not 35?
Because I'm writing the formula right now.
Okay, so it's always going to be less than the one that you want to find.
No, ma'am. I'm writing the formula. It's A sub 1. And it's kind of bad that it asks for 35 on this particular thing, but it's the first term in the sequence.
Okay.
And it's just unfortunately coincidental that 34 and 35 are very close to the same thing. So I'm sure I can see where that would be confusing. But basically, it's the first term. A sub 1 is the first term in the sequence that's given.
Okay, yeah, I see that now.
Okay. Negative 10 n plus 10, because negative 10 times a negative 1 is a positive 10 plus 34. So my explicit formula is going to be negative 10n, combine that 10 and that 34 plus 44, which it actually looks like they wrote it like this to get the fact so that it's not leading with a negative.
Mm-hmm.
So then you would plug in this 35 into that equation. Oops, my bad. To distinguish that I'm finding that A sub 35, that's going to be 44 minus 10 times 35. So that's a sub 35 equals 44 minus 350. So negative 306.
Okay, I got that. Thank you.
Uh-huh.
Hey, Miss Sparks. So I was kind of confused on these two types of problems because I forgot totally how to do them. So what is the formula? Is there multiple formulas for these, or is there just one
Yes, sir.
formula?
Well, there's multiple there's an arithmetic sequence formula,
Okay.
and there's an arithmetic series formula. There's a geometric sequence formula, a geometric series formula, and an infinite geometric series formula, which I will give all of those.
Are all of these going to be on the exam?
Yes, sir.
So all of our formulas and stuff will be on the exam.
Well, I will give you them exam day. Yes, sir.
Ms. Sparks,
Okay, cool.
Yes, Garrett.
I know that, don't you have different exams for Miss Wynn?
The exam is the exact same one. It's just y'all's is not multiple choice, but it's the exact same exam.
Will we still get the formulas too?
For the arithmetic and geometric sequences, yes.
Okay, good.
What did you say the other one was besides arithmetic and geometric for both? What was the last one?
It's also a geometric series, but it's an infinite geometric series. And Garrett, our exam reviews are exactly the same as well. It's just y'all's are not multiple choice. And I am showing my work for each individual one. So you can use my answers. Does that make sense? So like on number 26, the common difference is negative 10. The 35th term is negative 306. And the explicit formula is a sub n equals 44 minus 10n. So that should match your number 26, does it? The problem should be the same at least. Is that correct?
He muted himself.
Oh, okay. I just wanted to make sure that our problems were the same, but I did the same exam review for both classes. It's just I made this one multiple choice so that it would accustom you all to what you needed.
Mm-hmm.
Miss Sparks, I just want to know which of the sequences or formulas to use.
Okay, so great question. Hopefully the instructions will tip you off as to which one to use. Obviously, for number 24 and 25, when you're just asked to find the difference, there is no formula. You just need to know, they're asking about an arithmetic sequence. So that means there is going to be a common difference, which means I'm going to subtract the second from the first and the third from the second to confirm that the difference is common. For number 26 and 27, when it's asked about find the common difference, a specific term in the problem, and the explicit formula, then you're going to know that's going to be an arithmetic sequence. So that's going to, what you're then, if you'll think about it, that term, that word term is going to be the key thing. So you're going to be looking for a sub n equals something that has the d n minus 1 plus a1.
Okay, so how are we going to know if it's one or the other?
Now, with an arithmetic series, that should tip you off that means sum. So
Okay.
you're going to look for that summation symbol, which is this thing right here, that funky looking sigma. Okay? Series means sum. Sequence means like just you're looking for a sequence of things, but series means sum in a specific series. So I'm given a series of numbers and I'm looking for the sum or the addition of adding all those terms together. So that's how you would distinguish them. And the arithmetic series is that when you see the formulas, it's going to have an S on it. So
Okay.
for series or sum. Sorry, does that make sense?
Yes, ma'am.
I just want y'all to know the things that make me laugh. I said series so many times that my iPhone answered me because it thought I was saying Siri.
Thing. Are you going to label which which formula goes with which one, or is it just going to be there? Like, is it going to
It's
say?
just
Go ahead.
it's just going to be there.
Okay, so we're going to have to know which one is the arithmetic series and which one's the arithmetic sequence.
Yes, but let me give you another tip. Remember, here's the S. That should tell you series or sum,
Mm-hmm.
right?
Right. Okay.
And this right here, when it begins A sub n, that's term. So
Okay.
term has to do with sequence, and sum sum has to do with series. Sum and series, and then term and sequence. Does that make sense?
Yes, ma'am.
Okay. And
Miss
then
Clark,
the difference between a geometric and an arithmetic, there's going to be a D in the formula for an arithmetic for difference and an R in the formula for geometric for ratio.
Okay. Do we have any geometric ones on this review?
Yes.
Okay.
And I'll go through those. Yes, Braden.
are these due tomorrow or a Monday?
It is due tomorrow
At the end
for
of tomorrow?
but I am not taking them up. I will be going over them to see if they're complete,
Okay.
but I will let you have them over the weekend to study.
Okay, cool.
Does that make sense?
Yes, ma'am. So
Okay,
can we
cool.
do problem number 27, please?
Absolutely.
Thank you.
So you're looking for the difference, which 12 minus 19 is -7. So your difference is -7. You'll plug that in to your formula, which I've shown you up here is A sub n equals the common difference times n minus 1 plus the first term, which is 19. Distribute the -7 throughout the parentheses. -7 times n is -7n. -7 times a -1 is a +7 plus 19. Combine like terms. So that's your explicit formula,
Okay.
which sometimes they write it the other way to make sure they're not leading with a negative. And
So
then
your
you're
answer would
looking
be
for the
C, correct?
27th. Yes, you're looking for the 27th term. So you would have A sub n equals 26 minus 7 times 27. And I'm doing the whole thing because Miss Wynn's class does not have multiple guess answers.
Oh, crikey.
So 26 minus 189 minus
It is -163.
-163. Thank you, sir.
Yes, ma'am. Which I got my calculator fixed, so you don't have to have a funeral anymore for it.
Oh, I'm so glad. Oops, I didn't do the explicit formula, which is right there.
I revived it, so it's okay.
Praise the Lord. So the common difference is -7. The 27th term is -163. And the explicit formula is A sub n equals 26 minus 7n.
Cool. Thank you.
All right. The summation. The formula for an arithmetic summation is n, which is the number of terms within the sequence, times the first term plus the value of the first term plus the value of the last term, all divided by 2. So the number of terms is the top number minus the bottom number plus 1. And I know you're thinking to yourself, why, Miss Sparks, why didn't you just go with 25 since that's on the top? The reason for that is because if you will look at number 30, that would be 11 minus 5, which equals 6, plus 1, which equals 7. And that's the number of terms in that series. Okay? Does that make sense?
So that's going to be your n, the multiple n.
7 will be your n for number 30. 25 will be your n for number 28.
Okay.
So that's the reason why I go through that, just to make sure. If this bottom number down here is a 1, if it's a 1, obviously you can use the top number. If it's not a 1, you want to make sure you use this little ditty of a formula. Okay?
Okay.
And that won't be on the formula sheet. That is something that you're expected to know.
Okay.
So, all right. So the summation, or the sum of all the terms, so that's going to be 25, because that's the number of terms. That's what that n is. Times in the top, you want the value of the first term, which basically that's going to be 10 times 1, which is 10, minus 9, which is 1. So the value of the first term is 1. The value of the last term in the series, in this case, is going to be the 25th term. So that's going to be 25 times 10, which is 250. And 250 minus 9 is 241. So 1 plus 241 is 242. And 242 divided by 2 is 121. So my final answer should be C. The rest of it's just calculator work once you get everything filled out. Are there any questions on that? Did Garrett leave? I'm sorry?
I said I didn't understand any of that.
You didn't understand any of that?
Wouldn't you just distribute 25? Because I didn't get the same answer.
Did you get the value of the first term?
20, like, talking about 25?
No, sir. You have to use this formula up here. So that's the number.
Yeah, this is like the worst section for me.
Oh, okay. So it's I think, if I'm not mistaken, wasn't that when your grandpa got sick?
No.
Not to bring up anything personal and sad, I'm sorry. But anyway, I would.
Is that here too?
I'm sorry?
Is that A1 plus AN over 2?
Over 2. Yeah, that's a 2. That's a beautiful 2. So you're looking for the value of the first term plus the value of the last indicated term for the series that it's asking for. In this case, it was 25. So you have to plug those into that equation.
Will
So
that
you're
formula be
adding,
on the,
I'm
will
sorry?
that formula be on the exam too?
Yes, sir.
Okay.
It actually, in my class, I'm giving a formula sheet.
Why aren't the
In
classes the
your
same?
in your class, the formulas are actually written, are printed on the exam on the pages where they'll be used.
How come the tests are different? So
Just
I think having
because
multiple choice is a big advantage.
um, because she wants to make sure she's given partial credit, and the only way that I do partial credit is if you're like like I'll go back and review, and if you write on the test, like say for instance somebody had a 79, I'll go back through and see if there's any place that I can give partial credit. She gives partial credit throughout the whole thing. Mine are only if it's borderline. So like if you're borderline A to B or B to C or God forbid C to F, I will go back and give and look for partial credit, and she gives partial credit from beginning to end.
I don't know. I just think all the classes should have a standardized exam.
I understand.
Because I really struggle in this class, and I definitely would benefit from having a multiple choice.
Yeah. It's
I think
just
I
that's
understand it now.
that's just what she's chosen to do. So
I think the formula did help, though. I think I'll be able to understand it now.
okay, good. I'm glad. On number 29, once again, you'll just use the same formula. So you've got your 8 minus 1, which is 7, plus 1, which is 8. That's basically finding the number, the end part of terms in the series. And then you're going to plug in the number of where it is to find the value of A1, which that's going to be 8 minus 15, which is negative 7, plus the value of the 8th term, which that's going to be 8 times 8 is 64, and 64 minus 15 is 49, all over 2. So you'll simplify what's inside the parentheses first. So that's negative 7 plus 49. So that's 42 divided by 2, which is 21. And 8 times 21 is 168. And sometimes on multiple guess tests, they put things that are really, really close so that if you are off, sometimes they can actually be a stumbling block too. So there's pluses and minuses. On number 30, I already actually found the number of terms earlier when I was distinguishing the differences between 28 and 30 on how you find the number of terms. You take that top number that's on the summation symbol, which in this case is 11. You subtract the bottom number, which is 5, and then you add 1 to your final answer of that to get the number of terms within the sequence. So in this case, it is 7. So then you take the value of the first term, which in this case, you're going to substitute a 5 because the first term in the series that they're asking about is the fifth term. So 4 times 5 is 20, and 20 minus 8 is 12. And then we're going to find the value of the final term that they're asking about in this series, which is the 11th term. You'll plug that into the original equation to find its value, which 4 times 11 is 44, and 44 minus 8 is 36. And then all of that is divided by 2. So you have 12 plus 36, which is 48. 48 divided by 2 is 24. And 24 times 7 is 168. So your answer is D. Do you all want me to do 31, or do you feel pretty good about these so far?
I'd like to see 31.
I'm sorry?
I'd like to see 31.
Okay, cool. All right, so to find the number in the summation series that they're asking about, you take the top number, subtract it by 3, which is going to be 19, then add 1, and you get 20. So the number of terms in the series is 20, multiplied by the value of the first term in the series, which in this case is going to be the third term. 10 times 3 is 30, and 30 minus 1 is 29, plus the value of the 22nd term, which is going to be 10 times 22, which is 220, minus 1 is 219, all divided by 2. So 29 plus 219 is 248, divided by 2 is 124, and 124 times 20 is 2480. How is that for everybody? Does that ring some bells?
Yeah.
Is it better?
Mm-hmm.
Okay, good. Are Braden and Rachel still with me?
Yes,
Yeah.
ma'am.
Okay. Did anybody else join?
Anna and Alex have.
Okay, cool. Hi, everybody. Just want to make sure I address people. Okay. All right. Now we're moving on to the geometric sequence. The geometric sequences, these are going to have a common ratio. Much like finding the common difference, what you're going to want to do is work with your second to first and your third to second to make sure you're getting the common ratio. But instead of subtracting this time, thinking about ratios, that means I'm looking at a division problem or a fraction problem. So 10 divided by 2 is 5. That's the second to the first. And then 50 divided by 10 is also 5. So my common ratio is 5. And then from there, you're going to use the formula for a geometric sequence. So much easier. Once again, a term formula always begins with A sub n. A summation or series formula always begins with an S. So kind of trying to distinguish between term and sum, that hopefully that will help you. A sequence deals with a term, a series deals with a sum. So try to maybe, when you're studying, to correlate those words: sequence, term, series, sum. So with your sequences, for my class, since you're getting a formula sheet, you're going to be looking for, when it's a sequence, a formula that starts with A sub n. All right. So then you will have a common ratio in it. So you're also going to be looking for a formula that has an R in it, distinguishing the difference between a geometric and arithmetic sequence. So this one is the first term times the ratio, the common ratio, all raised to the n minus 1 term. So for this one, the explicit formula is going to be A sub n equals that first term, which is 2, times the ratio, which we have discovered is 5, raised to the n minus 1 power. That's why I say it's so much easier. There's really nothing to distribute for this one. And then we're supposed to give the next 3 terms in the sequence. And really, you could plug it back in if you wanted to find the next 3 terms, but basically all you're doing is multiplying 250 times 5, and then that times 5, that answer times 5. Does that make sense to everybody? So I would take 250 times 5, and that's going to be 1250. And then multiply that answer times 5, and then that's going to be 6250. And then you're going to take that answer times 5, and that's going to be 31250.
Miss Sparks,
So
can you
for
explain?
yeah,
Sorry, can you explain this problem by plugging it into the equation you just made?
yes, I absolutely can. So what you would do is, it says to find the next 3 terms. So if you've got 1, 2, 3, 4. So I would be looking for the 5th term. So 5 raised to the 5 minus 1.
Okay.
So that's going to be raised to the 4th power. So you have to do the power first. So 5 caret 4 is 625 times 2 is 1250. And then you would do A sub n, but in this case, it's going to be the 6th term. This one was the 5th, right? Because we were finding the 5th term.
Right.
So that's going to be 2 times 5 to the 5th, which you have to do the exponent first. 5 to the 5th power equals 3125 times 2, which would be the 6250. Does that make sense?
Yeah, that makes sense. Thank you.
Uh-huh. Do you want me to do the 7th?
The 7th term? Oh no, I already figured it out.
Okay. All right. Okay. So for number 33, the common ratio is going to be the 2nd term divided by the 1st term. That's 2. We also want to confirm that it is geometric, because the first part of the instruction says determine if the sequence is geometric. It's only geometric if the ratio between 1st, 2nd, 3rd terms are all common. So you want to confirm it by doing an additional problem or additional ratio. Check the ratio on them. Does that make sense to everyone? The common ratio is 2. So to plug that back into the formula, A sub n equals, and then this is where your first term, which is 1, times your common ratio, which is 2, all raised to the n minus 1 power. So for me, yes, you could plug it back in, but when it's asking for the next three terms in the sequence, I would just actually take that final term and multiply it by the common ratio. Because that's going to move you along your exam a little quicker. Does that make sense to everybody?
So wait, what did you get for number 32? A?
Yes.
Okay.
Determine if the sequence is geometric. If it is, find the common ratio and the eighth term. Now, Rachel, this is going to be one where you're going to definitely want to plug it back into the formula because you're not extending the sequence. You're actually looking for something further on down the line. So, first of all, the first thing that we want to do is confirm that it is geometric by taking the second term, dividing it by the first. We get a common ratio on this first part of -4. Then we'll take that third term, divide it by the second, and we once again get a -4. So the sequence is in fact geometric, and the common ratio is -4. To find the explicit formula, it's a sub n equals the value of the first term times the common ratio, all raised to n minus 1. Now, to find the eighth term, you've got 2 times 4, and then that's all raised to 8 minus 1, which obviously that's 7, but I'm just taking it one step at a time here. Now, once again, don't forget about order of operations when it comes to geometric sequences. Do not do 2 times 4 to the 7th power because you won't get the right answer. You absolutely have to raise 4 to the 7th power first. Does that make sense to everyone?
Yes.
It's actually -4, my bad.
Oh, yeah, that's my question. Is it supposed to be negative or do you make it the absolute value?
No, it's negative, and I forgot to put it in. Thank you very much for noticing. Look, my parenthesis looks like a heart now. So it's -4, and you definitely want to put that in parentheses. -4 raised to the 7th power, which is negative 16,384 times 2. And this is kind of where multiple guess could get ugly because you can see whereas if somebody didn't multiply it by that 2, you've got a pretty close answer on C. So our common ratio is -4. Our eighth term is -32768. And the explicit formula is 2 times -4, all raised to n minus n, which is D.
I have a hard time finding the explicit formula.
Okay. The explicit formula is, you're going to be given this, okay? It's the common ratio times, no, sorry about that. It is the value of the first term times the common ratio, n minus 1. So if you look back to number 34, a sub n, what's the first term? What's the value of the first term in the sequence? 2?
Yeah.
And then the common ratio, -4. And then that's raised to n minus 1. So that's it. For the geometric, it's not so bad. For the arithmetic, you have to distribute stuff. So that's it. So you're done with that one. Does that make sense?
Mm-hmm.
Okay, good. I understand it is difficult it's a little more difficult on the arithmetic because you have to distribute that common difference through the parentheses. So it is a little trickier to find the explicit formula on arithmetic than on common ratio. It's just kind of plug and chug on the geometric. I mean, on this one, on number 33, when you were multiplying by a 1, the 1 did drop because we had that in our original. But given the fact that you're not going to be on a multiple choice test, if you were to write it like that, I'm sure Miss Wynn would not count it wrong. Because 1 times anything is itself. And you're just showing that you know the value of the first term goes there. It's just dropped here because anything times 1 is itself. So, but other than that, it's pretty straightforward. All right, number 35, confirming that in fact it is geometric. So it's negative 4 divided by 1, which equals -4. Seems to be a theme. And then 16 divided by -4 is also -4. And hopefully Mrs. Sparks will remember to write it in the formula. So we've got a sub n equals the first term, which is 1, times -4, all raised to n minus 1. To find the 8th term, since we've already done this once before, I'm going to just use my answer. And then 1 times a -16,384 is a -16,384. So my answer for the multiple choice is A. But Garrett, for you, this is the explicit formula. This is the value of the 8th term. And this is the common ratio. Or you could write the explicit formula as this. Both are acceptable. Here or here. Understanding that 1 times anything is that anything. All right. Series. That should make us think sum. Sum and series are the same thing. The geometric series, sum formula is a sub 1, or the value of the first term, times 1 minus the ratio all raised to the number of terms in the series all over 1 minus the ratio.
Really quick, sorry, Miss Sparks, I got sidetracked. What did you get for 35? I got C.
It's A.
Okay. I'll rework that one then.
Okay. Yeah, because the common ratio is -4.
Okay.
All right, so the sum, what you're going to want to do is get the number in the series, which you want to take that, once again, it's kind of the same thing with the arithmetic. You want to take that top term, subtract by the bottom term for your number, and then add 1. But none of these look different. Like the bottom term is all a 1. So, but it would be 9 minus 1 equals 8 plus 1 equals 9. So you're going to say the value of the first term, which in this case is going to be, if you plug in a 1 here, that's going to be 4 to the 0 power, which is 1, and 1 times -3 is -3. And then 1 minus the common ratio. How do I know which one's the common ratio? Can anybody tell me? On number 36, if you had to guess what the common ratio was, what would it be? Anybody? Knowing what the explicit formula looks like, what do you think? Is it -3 or is it 4? How about if I narrow it down and give you a 50-50 shot? Nobody knows? Okay, the common ratio is the one, just like up here, that we associated with the exponent. Because the formulas aren't going to do you any good if you can't pull out and distinguish what is what. So the common ratio is the one associated with the exponent. So what number, what digit in number 36 is associated with the exponent?
The 4.
The 4. Good job. So it is 4 raised to the number in the sequence, which in this case is 9, all divided by, 1 minus the common ratio. Now, make sure you plug this in your calculator correctly, because you've got, if you're doing this, depending upon how you do it. Now, I know Braden can be kind of wicked on his calculator, but make sure you're using parentheses. So like, if you're going to put this whole thing in, my suggestion is to start with a parenthesis and then do -3 and then another open parenthesis, 1 minus, then another open parenthesis, 4 raised to the 9th power, close parenthesis, close parenthesis, close parenthesis, divided by, open parenthesis, 1 minus 4. And you should get this. Did you follow that with me? Or would you prefer I break it out?
I didn't follow you, but I still got it.
Okay. I'm just trying to make sure everybody, if you're using your calculator, to make sure, if you're taking it step by step, you want to make sure that you're putting that.
It's just sectioning things off. That's all it really is.
Yes, that is it exactly.
Miss Sparks, really quickly, can you jump to one of the infinite geometric series problems?
I can.
Thank you.
On this one, it turned out real cute to work out that way. I can. All right, let's do the infinite. And you'll know that it's infinite, A, first of all, because there'll be an infinity symbol above that. B, it'll say evaluate each infinite geometric series described. But the next thing that you want to look for, because it's not going to be that clear on an ACT or an SAT, the way you're going to know it's an infinite geometric series is because the common ratio is going to be less than 1 but greater than 0. Okay?
Can you
Actually,
show us the formula for this one, and then also can you scroll back up to show me the formula for 36 through 38?
yes, let me go ahead and finish this one first.
Okay.
This is the formula for an infinite geometric series. So it's the simplest, if you want to think of it like that. It's the simplest, okay?
Mm-hmm.
And usually you're going to end with some sort of ugly complex fraction, which I know you all dearly love. No, actually, you may not even. On this one, we definitely do, because you've got 6/5, which that's the value of the first term. The first term is always that beginning part. And then we've got 1 minus 1/4. So that's 6/5 divided by 1 minus 1/4 is 3/4. And now you keep, flip, change. Simplify before you multiply. And there's your answer.
Okay, thank you.
Uh-huh. Are you good on the second one, you think, or do you want to see it?
I think I'm good. You don't want to do that one for me. Thank you, though.
Okay. All right. Braden,
Yes,
there
ma'am.
is the formula for number 36, 37, and 38.
Could you also show me? I'm sorry, I just had to get my other notes together, but could you show me the one for the previous problem on the page before?
What? Which one?
Yeah, both of them actually.
Here's this. That's the geometric explicit formula.
Okay.
And what other one do you need?
The one before it.
That's the same thing. The geometric explicit formula is
Okay.
the same thing on that. It's the same thing because it's asking for that. Were you good on the arithmetic?
Yeah, I got the other ones. Yes, ma'am.
Okay. Math lab participants, would you like to see 37 and 38 worked out?
I would.
Okay.
Yeah, I'll just do 37
Okay.
and
So,
38. Yeah.
So the summation is, it's going to be 9 terms. Okay. And you're looking for the value. And the reason why I got the 9 terms, it's the top number minus the bottom number plus 1. So 9 minus 1 is 8, plus 1 is 9. Okay. So that's my number of terms. I'm looking for the value of the first term. Well, Miss Sparks, there's no first term really given here. There's only a common ratio because you've already told me that the common ratio is the one associated with the exponent. So if you do not see a number before the common ratio, just like we had on number 35 here, and also I believe we had it on 33, when the first term of a sequence is 1, it's typically not shown because 1 times anything is itself. So I know the value of the first term in this situation is going to be a 1. Does everyone understand that? Then my common ratio is 3, all raised to the n minus 1. What was my n here? It's 9. So n minus 1 is 8. All over 1 minus 3. So once again, be careful when plugging all of this into your calculator because junk in, junk out.
Wait, really quick. How do you find A1?
That's what I just explained.
Oh, sorry. I was trying to write another problem down.
I basically A1 is this first term here.
Yeah.
And when it's not given, I said it was like 35 and 33 that we had, where when that first term is a 1, it's not going to show up in the explicit formula because 1 times anything is itself.
Okay.
So
Is this the thing where it's like you one times one, or what, A times 1 equals whatever, and then you get subtract or something like that?
no, I think you're thinking about the top and the bottom term to figure out the number of terms.
Yeah, I think I am too.
But I'm not sure because I don't know that I perfectly understood the question.
Sorry.
No, it's fine. I feel bad when I don't understand a question because I want to make sure that I answer them. I just so this is going to be negative. Okay, I've got 3 to the 8th. And then 1 minus 3 to the 8th. I got negative 6560 all over negative 2. Anybody else get something different?
Wait.
So
I got negative 6562.
yeah. Trying to figure out what I did wrong. Because I don't see those as one of the answers. Do y'all?
No, plus I got a different answer too. Like, it's all weird.
We're supposed to get this.
No.
Hey, Rachel, are you still with me?
She is not. She ripped out on us.
Alex or Anna, are you still with me?
I'm here, and I think that I think it's 3 to the 9th instead, because when I did it with 3 to the 9th, I got B.
But it shouldn't be because it's 3n minus 1.
Oh no, she's right.
Because the formula, I looked it up, and it's
Yeah, it's
the
right.
sum
You're
equals
right.
the first letter. Yeah.
You're right because I was doing n minus 1 from here, but it's actually n up there. My bad.
Yeah, I got B too.
I knew somebody would catch my mistake for me. So yeah, like I said, remember when I said junk in the calculator, junk out? I was absolutely correct. See, you got to watch me like a hawk. Thanks, Alex.
You're welcome.
9841. All right. It helps if you put the formula in right. All right. So Miss Sparks will do this one right then. So I've got let's see. The value of the first term, which is going to be negative 3, times 2, and then Miss Sparks will do this one right. It's supposed to be n, which is 9, all divided by 1 minus the common ratio, which is 2. So 1 minus 2 to the ninth is negative 511. And that's going to be over negative 1. Oh, and then negative 511 times negative 3 equals 1533. All divided by negative 1, which gives you negative 1533, which is B. And then for 40, you plug in.
I got -4. So I got A. Is that correct?
Oh, I'm sorry. For number 40,
Yeah.
it is A.
Booyah.
Good job.
Thank
So you
you.
get -6 over 1 minus a minus 1/2, which that's going to be -6 all over 1 minus a minus 1/2 is 3 has a positive 3/2. You keep, flip, change, and get -4. Trig, everybody's favorite part of school, right?
Hey, Miss
I mean, it's
Bart.
better than what we were doing a minute ago.
Oh, really? You like it better than that? Yes,
I don't
Braden.
like either one, but this one's better.
Yes.
Tomorrow, are we also gonna be? Did you say we're gonna be showing you this worksheet in the beginning of class, or after we gone over it in class?
Oh, we're definitely going to check at the end of class. I'm going to try and set a timer to have a assistant come in so that I can go through the last 5 minutes because I want to use all of it that I possibly can to answer questions.
Okay.
But that's why I'm trying to do Math Lab to make sure I go through almost the whole entire thing between classes and Math Lab.
Yeah, because I gotta go right now, but I was just checking to see like if I could be able to still like go over and stuff. Because I can look at the math lab later tonight. And I can
Okay.
do it later tonight.
Yeah, just skip through the part that you were in and then go to the last part.
Okay. Alrighty. Thank you.
Mm-hmm. Hey, Garrett,
Yeah.
are you in Miss Wynn's second or third period class?
Second. Is she the same turn-in schedules as you do?
I don't know. I don't know if she's got the same schedule about turning in as I do. So you may want to email her about that. And I also wanted to let you know that on Mother's Day, I am going to try to do a short math lab in the evening. Please spend time with your mom during the day, but I am going to try to do a short math lab for anybody who has any final questions before the exam on Monday.
So I have a question. Are you just
Yes.
going to go over the rest of the packet so we can kind of understand how everything works?
Well, I was going to do that, but I'm going to make sure that anybody who's still in Math Lab, if they have any specific questions, I would address those first.
I'm currently the only
So-
one here.
Oh, okay. Did Alex leave?
Yeah.
Oh, okay.
Have you already done the problems before? Like, have you done like the early problems?
No, I started with the series today
Oh, okay.
because I went through 1 through 20 something in class so far.
hmm
But so you don't have the ones before that?
I mean, I have most of them, but like, are you guys going to do like 41 to the end? Because I have
I don't know. I don't know that I'll have
history
time to do all of those today, but what I will try to do is do at least one from every section. Let me see. For today, and then maybe try to hit the others later. But I'll try to get through at least one from every section so you'll have at least an example. Okay?
Because I have to go study for a history test there tomorrow.
Okay. Well, I'll try to do one from the first one in every section to at least get you started.
Okay, thanks.
Uh-huh. Okay. So number 41 for the trig portion. When you have sine, when you're trying to find sine, if you're given tangent 4/3. So what you want to do is remember what sine, cosine, and tangent are. And good old SOHCAHTOA can help you on this part. Knowing that tangent is opposite over adjacent, and knowing that sine is opposite over hypotenuse, you know that you have the numerator value for sine at 4, but you don't know what the denominator value is, or the hypotenuse value. So what you're going to want to do is it's 4 squared plus 3 squared equals h squared. So 16 plus 9 equals h squared. So 25 equals h squared, and 5. So then you take the square root of both sides, and 5 equals h. So now you have your hypotenuse value, which is 5. So sine theta is 4/5. You would basically do the same thing. I'm going to go ahead and do 42 because you've got that secant, which we know secant is the same thing as 1 over cosine, or the inverse of cosine. So if you are really thinking about that, then you know if it's the inverse of cosine, all you have to do is flip this. So number 47 is 7/9. "43 for secant, remember that's the inverse of cosine. And cosine typically is adjacent over hypotenuse, right? So if it's the inverse, it's going to be hypotenuse over adjacent. So that's what we're looking for. Here in tangent, we know that to be opposite over adjacent. So we have the denominator as 8. So you would be looking for the hypotenuse value. So that's going to be 15 squared plus 8 squared equals h squared. And 15 squared is 225 plus 64 is 289. And 289, the square root of 289. I thought it was 17, but I wanted to make sure. Whoops. In my head, I was trying to do all of that. So that's how you do that section. Number 45, we're looking for cotangents, and we're actually given, here's where theta is, so you want to think about that. We're actually given both leg measurements with respect to theta. You've got tangent is opposite over adjacent. So that would be 15 over 8, opposite over adjacent. So, but you're looking for cotangent, which is the inverse of tangent, which that's going to be 8 over 15. Cosine is opposite, no, is adjacent over hypotenuse. And we are given adjacent over hypotenuse. So how easy could that be? Adjacent over hypotenuse. Secant is the inverse of cosine. And cosine is adjacent over hypotenuse. So that's going to be hypotenuse over adjacent. And we're actually given adjacent over hypotenuse, but it can be reduced. These were easy. Or did Miss Sparks reduce those right? Apparently not. Oh, that's because she didn't write it right. Hypotenuse over adjacent. Now Miss Sparks will try this again. 3 goes into 15 5 times. 3 goes into 12 4 times. Sweet Jesus. These were easy, but you can't do the simple math. You're going to be struggling. All right. To find the measure of each of the sides, you want to look at what is given. And you are given adjacent over, you're given this adjacent over opposite. Well, you don't have to write it like that, Miss Sparks. Miss Sparks needs her math lab participants to help her. It's so much easier to talk to people. You're given both leg measurements, let's put it like that, which would tell us that you're going to use tangent. And tangent is opposite over adjacent, which would be x over 11. So you're going to want to find tan 42 degrees. Lord help Miss Sparks. So tan 42 times 11 is 9.9. Let's see if I do a better job on this one. All right. So we've got an angle at 63, and we're given a leg that is opposite over hypotenuse, which opposite over hypotenuse is sine. So sine 63 2 times sine 63 is 1.78 or 1.8. On this one, we're supposed to find the angle measure. So this is where you're going to use your inverses. But you want to look and see what side you're given with respect to your theta angle. And we are given an adjacent side. So adjacent over hypotenuse. And so that's going to be cosine. So the cosine of theta is equal to 4.9 over 14, which means you're going to find the inverse of that. So you would plug into your calculator second cosine 4.9 divided by 14. And you do want to make sure that your calculators are in degrees for these problems, so that you want to make sure. A lot of them will tell you at the top, it's got like some identifying marks at the top, like mine right now says normal, float, auto, real, and then it says degree. If that actually says radian, you're not in the right mode. But that's how you do those. And then converting each degree measure into radians. You just want to make sure you're using the right, and each radian measure into degrees. So you want to make sure that you're using the right ratio, which is going to be pi over 180 or 180 over pi, depending upon what you're trying to get rid of. Like on number 53, you want the part you're getting rid of, you want the pi to be at the bottom because you want the pi's to cancel. So this would cancel, and then 36 goes into 180 5 times. So you want to simplify before you multiply. And that's going to be 865 degrees. So on this particular one, you would use the 180 over pi. No, my bad. I know what I'm doing. I'm telling y'all, it's harder to do math lab without participants. You would do pi over 180 because you're trying to get rid of the degrees, Miss Sparks. So the degrees cancel. And then you would simplify before you multiply. $15 goes into both of them. So your answer is 23 pi over 12. So that's how you do that section. Find a positive and negative coterminal angle. So on this one, you're just going to add 360. So that's going to give you 570. And you're going to subtract 360. That's going to give you negative 150. For number 59, to find coterminal angle, you know you're going to add 2 pi to this. So you can do one of two things. There is the calculator trick where you can do 3 divided by 2 math, 3 divided by 2 plus, or in parentheses, 3 divided by 2, close parentheses, plus 2 math, enter, enter, which would give you 7/2 pi. Or you can convert this 2 pi to 4 pi over 2, which is the equivalent of 2 pi with a denominator of 4. With a denominator of 2, I'm sorry. So then if you were doing it using that same method, you would get negative pi over 2. Whoops. Got the right answer, circled the wrong one. One of the downsides of a multiple guess test. All right. For the last ones, to find the value of each exact trigonometric function, I believe that's the remainder of the test. This you would use the unit circle for, and you will be given a unit circle. But I caution you, make sure that you're understanding what each of the, I was going to try to pull up a unit circle for you guys so you could see how I did it. Let me see. So cosecant, that is the inverse of sine, okay? And when you're using the unit circle, okay, we know that sine is the y value. So the cosecant is going to be 1 over y. So you would then go to your unit circle. Well, and look at 180. You can see I've been drawing all over this. Look at 180, and that's the y is 0. So 1 over 0 is undefined. So it's A. Cosecant of negative 210. Basically, what that means is that I'm starting at this position over here and going in a clockwise fashion, to 210 degrees, which is going to be the same as my 150, because I'm going 30, oops, that's a mess. I'm going 30 past the 180 mark, okay? Which is 150. So then I'm looking at cosecant, which once again is 1 over y, and y in this case is 1/2. So I keep, flip, or you could even take the 1/2 and just know that it's the reciprocal of that. But if you wanted to, so you keep, flip, change. So if you wanted to kind of remain consistent in your approach, because sometimes you might have 1/2 over the √3/2 and stuff like that. So you keep, flip, change. Make sure that you're doing that same process. But the key here on this one was the fact that this was negative. So you have to start at the 360 mark and go clockwise versus counterclockwise. You would not want to go to the 210 mark and use that, because that's going to give you a negative y. Make sure that you're reading whether this is negative or positive. So I think I'm going to handle number 63 because it also is negative. So that means I'm going to want to travel in a clockwise fashion as opposed to a counterclockwise fashion. And it's 300. So that means I'm going to start, go to 180, and then to get to 300, I'm going to go 120 more. Which should take me to 60. Right here. And then I'm looking at secant, which is 1 over cosine, or the inverse of cosine. Which is 1 over x. So I'm looking for the x coordinate, which is 1/2. Or the inverse of 1/2, which is a. Tan 300. This one, you're just traveling in a regular direction. You're looking at 300, which is right here. And tan is y over x. And remember, when you have complex fractions divided, all you have to do is pay attention to your numerators of each of the complex fractions, because the denominators would just cancel. So you would have -3 over 1, which then reduces to negative √3, which is d. So tan 300 equals -√3. And I'll leave 65 just for you to have one to kind of try on your own. And please come to class prepared to ask any questions to Miss Wynn or I over anything on these worksheets that you don't quite understand, so that we can finalize this. And I'll try and do a short math lab on Sunday, particularly focusing toward first and second periods for your finals. And then obviously on Tuesday, I'll have another math lab for the third period classes. But anyway, I hope y'all have a good day today, and thanks for listening to Math Lab.